Okay, guys, we'll kick it away on time. I'm going to horribly butcher his surname. Please apologise, Michael. But yeah, Michael Pogrebisky, and he's doing a presentation on serverless infections. Malware just found a new home. If you can all give him a big round of applause, guys.
Yeah, thank you. Thank you so much. So good afternoon, everyone. I understand this session is after lunch, so it's a bit tricky one. So I'll try to make you guys awake and interested, hopefully. It is a pretty interesting and exciting subject. Okay, so what we have on the agenda today. So first of all, we're going to talk a little bit about what serverless is. It's a new concept, so it does need some intro and maybe refreshment for someone who has already some information about it. Then we'll talk about specifically Aws Lambda, which is the most popular platform for serverless today. Then we will actually try to do some nasty stuff with Lambda, and it's fun. Then we'll talk more about Lambda security and how what you're going to see can be prevented with what AWS provide today. And we'll also talk about some key takeaways. And that's it. So first of all, by the show of hands, how many here have used or heard or done anything with serverless? Wow, a lot. Just for games or for anything real? Like, can someone show their hand if they have done something for real, like real application development? Okay, just one person. So lots of people heard about it, but not many have already started using it. And it's understandable because it's a new paradigm and it's a very different one. And we'll see in which ways it's different. Just one thing to mention before we proceed. Cloud is not a thing of its own. At the end of the day, when you run some code, it runs on a computer, and if it's in the cloud, it still runs on a computer. Let's just keep it at the back of our mind. Okay, so evolution. From the evolution standpoint, how did things progress to where we are with serverless? So in the past, not so distant past, we used to have data centers, and in data centers you had servers, you had storage, you had network, and organizations had to manage it, and there was lots of overhead related to it, and lots of costs associated with it. Now, virtualization started developing around that time, and you could run virtual machines on physical hardware and play with this stuff and utilize it in a flexible way to an extent, but you still had to manage the hardware. The next stage is the transition to infrastructure as a service, which is what we know today is Amazon EC2 or Azure Cloud and Google and others. And basically here, what you have, you still have to deal with instances of operating systems, so you need to bring up a Linux box or a Windows box, but you do it on someone else's infrastructure. So basically, you go to a cloud provider, they give you infrastructure, and you still need to architect your system. You still need to decide, I need this amount of Linux boxes and this amount of Windows boxes, and I install this part of the software here and that part of the software here, and the specs should be this and that, and they communicate in a certain way. The next stage, or not necessarily next stage, but some of the software products that people use today are consumed as platform as a service. Some good examples to these are Office 365 or Salesforce. So basically, from your perspective as an end user, you have an application. And this application can be provided by a third party, or you can create an application that is provided within the organization, but is still treated as an application from the user perspective. And someone else is dealing with all the particulars of deploying it and managing it and migrating it maybe to the new version and maybe to different architecture and stuff like that, you don't care about this. All you care about as a user is doing the business functions that are enabled by this application, and maybe doing some administrative functions related to this application, such as creating users and stuff like that. And now we have serverless. So what is serverless? Basically, function is a unit. So it's not even an application. Now you have single functions that you can deploy, and they can scale, and everything else is taken care of by the platform provider. Okay? So it's a significant paradigm shift now. You don't deal with anything related to either hardware or operating system or application server of this or that kind. You just write a bunch of code, you send it over to the serverless infrastructure provider, and it's out there ready to run. Okay? In terms of the lifespan of these things that we've spoken about, so for data centers, they used to be deployed in months and lived for years. Virtualized cloud deploy in minutes and live for weeks. Roughly, could be weeks, could be months. Containers, it's like the next logical step where you don't even care about operating system. You just have a container which you can deploy really quickly in seconds, and they can live for hours, maybe days, maybe months. With serverless, when you deploy a function, it is deployed on demand. So basically, it's not even deployed before you trigger it in some way. And then when it's deployed, it lives for whatever amount of time it needs to live, but usually it's very short. So it may live for seconds, sometimes it may live for longer. And when it's not needed, it's disposed of. So basically, it's a very, very short time span. Now, this is how you work with these Lambda functions. So obviously, you need to develop it. So that's regular development work, writing some code in an IDE or stuff like that. Then you push it to the infrastructure provider. In this case, it's AWS. And it sits there as a passive instance. And basically, until it's used, it's not even deployed. So only when something triggers that particular function, only then it's deployed within a disposable container very quickly. Then it's used, and then it's cleaned up. Okay, so it's a very different kind of life cycle, especially from the deployment perspective, from any other paradigm we've been dealing with so far. So benefits. There are some obvious benefits of using serverless. So first of all, it's very, very scalable. And scalable not only in a way that it can scale, because even today with EC2, you can stand up as many servers as you need and stuff like that. But with EC2, you have to actually do it proactively. So if you realize that you need more computing capacity, you need to bring up a new AWS server, and you need to be aware of this. It's an action that you need to do. With serverless, you deploy the function, and then whatever needs to be deployed for this in terms of provisioning hardware and operating system, etc., it's all happening behind the scenes, and it scales to whatever capacity you need without you even being aware of this. So it's a huge advantage in terms of scalability. From operations perspective, again, you don't need to take care of these deployments, to this box or that box. It's all done automatically for you. You don't even care. You don't know where this is happening from the geographical perspective, from the data center perspective. It all happens automatically for you. And so from the deployment perspective, the only thing that you need to do is when you need to update the function, you just push the new version of the function. And that's it. And it's ready to use. And because of the nature of the flexible nature of it, it can drive your cost down. If you think about how the costing of an EC2 solution works, is you spin up a machine, it's up and running, you're already paying for it. Even before you even install your application and deploy your application, you're paying for an EC2 instance for as long as it's up and running. Here, the deployment the actual deployment of the container is happening automatically when it's triggered, and then it's cleaned up, and that's it. You only pay for the time when it's up and running. So from the economical standpoint, it's very, very beneficial because it really is using the computing resources only when needed. Now, there are also some downsides. So first of all, it's a new paradigm. So as any new paradigm, it takes time for the community to basically work out how to utilize it. It's probably not suitable for every kind of application you can think of. If this is an application that has to be up and running and run long workloads and stuff like that, it's probably not the most ideal paradigm, not the most ideal environment to utilize. Okay, so there are some things that make sense or are better fit for it, and some others that are less of a fit. It is a bit slower when it comes to the actual invocation of the function, because if you think about how it works, I mentioned it previously, the function is deployed in a disposable container on the trigger. So it actually does take some time for this container to be deployed and run. And obviously the provider, Amazon in this case, do provide some means of caching and speeding up these processes. But you will actually see in the demo when something changes and a new version needs to be deployed, and it's all happening automatically. You don't need to do anything proactive for that, but it does translate into some slowdown in the execution. Okay, so somewhat it is slower. There is a big problem with monitoring. Now, probably it's a current problem because I imagine that Amazon and others will need to come up with solutions for that, because what's happening today is that it's really difficult to understand how much workload is actually being experienced on the server side and the exact cost implications and stuff like that, simply because you don't have any reliable means of monitoring what's happening, because everything is behind the scenes. So again, I imagine at some stage the provider will come up with a suitable means of monitoring, but they're not there yet. And the last one, it's platform dependent. So I kept mentioning AWS, and I will mention others in a minute. But when you create a serverless function, you create it for a certain provider. Basically, you can't just take this very same function and easily port it to another provider, because they have a different way of deploying stuff. They have different functions, different triggers, different means of interacting with storage and stuff like that. So lots and lots of things are different. So when you create an application like that, it is created for a certain platform, and then you're kind of locked into that platform. Okay, it's not like when you create a Java application and now you can run it anywhere. And if you're not satisfied with Amazon, you can switch to Azure tomorrow with no hassles. This is not the case here. Okay. Now, what kind of players do we have in the field today? So we have some commercial platforms. I mentioned AWS Lambda. There is also one by Google called Google Cloud Platform. There is also Azure Functions and IBM Cloud Functions. I was surprised to see that there are some open source players here as well. But yeah, you can use them, to play with stuff, basically. Let's do a quick comparison of the big ones. So obviously, AWS Lambda is there for the longest. It's the most mature one since 2014. It has lots and lots of hooks, and we'll talk about this in a minute, into their existing offering. It has wide language coverage, and the demo that I'm going to show you is based on it. Google and Azure are much less mature. They only started appearing in 2016, so about 3 years ago, and they're still more or less in beta stage. They do add more and more capabilities. So for example, later in this presentation, I'll compare some security aspects of these. And one of the security aspects is related to making modifications to the code via an API. So when this presentation was written a couple of months ago, there was no capability like that, but I just checked there is already a capability like that. So they keep evolving, and it's limited to JavaScript only over Node.js. Azure is also quite new. It's probably the biggest advantage is that it's really well integrated into Microsoft DevOps toolset, TFS, Visual Studio, etc. Okay, more about AWS Lambda. So as I said, introduced in 2014, has useful and widely used runtimes that are available. So we see Node.js, Python, Java, Go, .NET Core. Now you can see from here, and this already kind of hints it, that it all runs in Linux containers. Okay, and this has implications on the security stuff that we're going to have a look at soon. So Linux container is the basic runnable unit with AWS Serverless. And in terms of triggers, there are many triggers that can be used to trigger a function. So you can use it, you can trigger it via a REST API gateway, you can trigger it with S3 update, IoT button, etc. So it is really well integrated into the AWS toolset as you see it here. Okay, some common use cases for AWS Lambda. So I mentioned previously, so it's not suitable for any application or every application. But here are some really prominent use cases. So mobile functionalities backend, IoT bots, bots and chatbots and stuff like that. So things that really need to be deployed and interact with some front end on more or less ad hoc basis. That's a common use case. In terms of harnessing the scalability, you can think of scenarios where you use it for things like image processing or even brute forcing in the security context. So you could potentially write a brute force function and deploy it as a serverless function, and then end up with a huge bill from AWS because it was deployed on 1,000 of computers and you didn't even realize this is going to happen. And then also Alexa skills. Alexa is the personal assistant from Amazon, so you can also develop some so-called skills, which is an extension, and the back end of it can be deployed as a serverless function. Okay, so it's great, right? It sounds like a brave new world out there, and what else could we ask for? What are we here for? Security, right? We haven't spoken about this one yet. Okay, so what's happening there from the security standpoint? So first of all, good stuff. So it is running its own isolated environment, so it means that the damage is limited. Yeah, well, potentially. We'll see, or presumably. The environment is disposed of after the run, so no stored persistent damage. Again, presumably. We'll see that this can also be worked around. Okay, so our research team decided to take up on a challenge, which is create a code injection in a Lambda function and exploit it, and do it in a persistent, viral way. Okay? So this guy over there, Shimon Ashkenazi, he is one of our developers from the research team, and he is the one who created all these demo applications I'm going to show you, and he is the one deserving the credit for those. Okay, some of these are based on a paper by Rich Jones, one of the prominent security guys in the States. So basically, our guys took his ideas and kind of built on top of them. So this is our application. There is a main function, and then there are two functions that are called from within it, either users or cars. So this is from the architecture standpoint. So we have three functions here. And this is how the application looks like. Yeah, the UI sucks, I know. But basically, what happens here is that the outside frame is the main, and this visitors, this thing is provided by the main. But then this piece of information here is provided by either cars or users. So it could be either coming from cars or from the users. And the function itself is a part of the URL, and then the parameter on the URL is actually the number of either car or user. So this way you can go from one user to another. So basically here what we're doing, we're trying it with different parameters. So we just loaded user number 1, then user number 2. And as you can see, it has different profile picture. And now we're going to the car, and then again, this is car number 1, and that's how it looks like. Okay, it's pretty simple. Okay, so what we're trying to do here, we're trying to exploit code injection. So I guess most of the people here are very familiar with what code injection is, but just in a nutshell, it's an ability to inject some code when the application is built in such a way that a code can be injected from input, from user input, and be executed by the application without proper sanitization. Okay? Okay, so this is the application. I imagine that you probably are not really able to see what's in there. You can probably see that there are some problematic things there, but let me just highlight the most problematic part of it. As you can see, there is some code that is built by the application, and then it's just thrown into a val. So obviously there are some things coming from the input, this one and this one. And obviously they can be manipulated, and there is no sanitization, so there is a place for code injection here. Now, what can we get from AWS Lambda itself? So it comes with lots and lots of useful information, and when you just browse the documentation, you will find some really interesting things there. For example, one of the things that you can find there is that there is an environment variable defined, which basically tells you where is the current application code, where does it reside on the file system, in the container while it's running, okay? Because, you know, the application is deployed as a part of the container has to have the code of the application, and this variable contains the path to the code. Okay, so let's try and see what's the value of this. So this is the URL that we constructed and using the code injection. So because we have code injection, we are able to run some code within the context of the application. And this is the URL, encoded URL. And now when we run this, we can get the result, which is the path of the application. So it's under var task, okay? Now, we actually didn't have to do this because it's already documented, and this is the default path where it's stored, but, you know, just to verify. Okay, so let's do the first exercise here. Let's try and exfiltrate the code of the application, basically extract the code of the application, okay? So this is our application deployed in the container. And this is where we want to copy it into. So this is our hacker instance. And what we are going to try to do is just copy the code from there to here. So this is our URL here. Basically what we're doing is, and again, remember, we're running in the context of the application. So we have access to everything. So we're running the star command, which basically creates a package of all the code of the application, and we know exactly where it is. And then we use curl to send it to our cxhack.ddns.net, okay? Now, you might think, pause for a second and think, wait, why does it even allow me to connect to some external application Well, it does. It just does. It's because by default, there is no VPC. So basically, you can connect anywhere. OK, so this is my hacker server. It's empty right now. Now I'm running the malicious code, the exfiltration code. It's finished running, nothing interesting here. And now I'm going back to my hacker server, and voila, I have the tar file. OK? And now I can open it and see the actual code of the application. And I can see that there is some data there that I really don't want to be exposed, like API keys, for example. Yeah, you don't need to take a picture of this. They have already been changed. So anyway, that's already something. Okay, so we managed to exfiltrate the code of the application without working too much. Okay, so what else we could do? So AWS provides an SDK, which basically allows you to do lots and lots of useful things on your application programmatically. Okay, so it allows you to manipulate your application programmatically. You can list the function, deploy new ones, update existing, and invoke by code. Okay, so this is all very, very handy, but as you might imagine, could be dangerous. Now, the role permission is authenticated by your AWS profile, but within the context of the function, and we are running within the context of the function, it's already authenticated. So if you invoke the SDK APIs, you're already authenticated, and whatever the API allows you to do, you are able to do when you're in the context of the application. Okay? So this is my new function, and what it does, it overrides the existing function by appending some additional stuff there. Okay? So here is what we're doing. We basically, this is our cars. Now we executed the updating code, and now you can see it's taking a little, not now. When we're reloading this page, it's taking a little bit longer, and this is because the application has already been modified, and you can see how. Now we injected some code there. Okay? It wasn't there. It wasn't there from in the first place. Okay? So we actually modified both the cars and the main. Okay? And this is the actual code that is doing it, and you can see what we've done here, and you can see that we appended some text here, and this is how we ended up with this result. Okay? Okay, but this was just a one-time infection. So let's say that someone has done this, your DevOps people discovered this, they restored the function, and everything is good, right? Okay. So this actually shows you how you can do it. So let's say that you have this reset function defined, you resetted it, and now it's gone back to the initial state. Okay? So the cars has been restored. The main has not been restored yet, though. Okay? Now let's try to do some persistent infection plus viral contamination, because what we actually want to do, we want not just to infect it one time, but we want to infect all the functions and make sure that if you restore some of them, when the ones that you haven't restored is invoked, it contaminates again, infects again the functions that have been restored. Okay? So let's say we had this situation, we managed to infect the users. It will then go and infect both cars and main. And let's say that if afterwards your DevOps people realized that there was a breach, they cleaned up the main and the users, but the cars has still remained infected. When it's invoked again, it will go and again infect the users and the main. Okay? So this is exactly the exercise that you can see here. So we're starting from the clean slate. So as you can see, the application is clean. Nothing changed there. We are now running the function that basically infects all of them by looping through them. So now when we reload, we see that we only did it for the users. So now the cars was not contaminated. Now we're loading the users. Again, it's taking longer. So now the users is infected. Now we're going back to cars. And again, you can see there is slight delay because the function has been overridden. And now it's already infected as well as the main. Now we're cleaning it up. We're cleaning the main. And so you can see the main was restored. We're cleaning the users. The users are restored. And then we're going back to users. You can see that users now will appear. And again, there is this delay. The users now appear okay, but we forgot to clean the cars. So we're going back to cars. You will see that cars is now still hacked. But when we go again to users, you will see that users become infected again because we failed to clean up everything. Okay? So that was fun. We basically managed to do persistent code contamination in a non-persistent environment, right? So there was an environment, someone created an application, we managed to contaminate it, and without going and cleaning up everything, every single function, there is still a potential of reinfecting, recontaminating the rest of the applications. Okay, so how it was all possible? So there are a few things here that kind of assisted us with this hacking exercise, aside of the code of the application, obviously, and we'll touch upon this a little bit later. But there is this execution role, which is what the function is allowed to do. And by default, it is quite limited. So by default, you cannot, for example, invoke the SDK, right? And another thing is limiting the communication. So the exfiltration exercise that we've done as the first step is possible because the VPC was not defined, but obviously if you did define the VPC and you limited the communications only to the channels that are allowed, whitelisted, then it would have not been possible. Okay, now, so I just mentioned that by default this permission of running functions like update and stuff are not granted. But what about using some third-party packages? So one of the packages that a lot of people use today with Lambda is this Claudia.js. So it's basically a package that allows you to deploy Node.js projects easily. And this is its title. And then it also says here that it does require full access, in the small print. Okay? So if you decided to use this as a package, as a part of your application, one of the things that you have to do is grant it full access. It may not look like a big thing, but it is, as we've already seen. Okay, so you can say, okay, this is, third party. Let's not trust the third party. This is Amazon themselves. This is AWS Labs GitHub. And here, they also require using full access in the samples they provide themselves. Okay? Now, we actually reached out to AWS to speak about this stuff and other things such as VPC. And they acknowledge that something has to be done about it. At least they acknowledge that they should fix the GitHub examples. Well, last time we checked, they were still there. Okay. Now, regarding VPC, so again, they made a decision to leave it open to the public. Now, whether it's a wise decision or not so wise decision, time will tell, but apparently they're trying to make it as easy for the users to consume, but obviously it has some implications from the security standpoint. Okay? So a few takeaways here. So first of all, remember that when you run a serverless, there are still at least two servers involved here. One which hosts a container, and the other one which hosts the source code. Okay, so serverless environment still has servers behind it, and let's remember that. We shouldn't forget about security. So spoke about sensitive data, spoke about role permissions and communications. We should keep all this in mind. And above all, we still should care about the basic application security. So if someone had scanned their code for application security using one of the tools, including our own checkmarks static application security testing, they would have found this code injection anyway, right? Okay, so this is just quickly showing you how this can be scanned with our product, with checkmarks assessed. You see, these projects are really very small. They're very tiny, so it doesn't take very long to scan them. It will probably take just a few seconds to get the result here. But at the end of the day, you will get your attack vector, and you will see that you actually have a vulnerability, and it just needs to be fixed regardless of whether it's a serverless function or not. So we're just going to see the result. So this is the vulnerability that was found there, and you can traverse the flow, and you will see that there is some flow here from user input into code execution without proper sanitization, which is what caused all these problems in the first place. Okay. So just a quick comparison of these platforms. I won't spend much time on this because, again, things are changing very quickly here. But you can see that there are some things that really need to be taken into consideration here. And the fact, for example, that there was no SDK for modifying the code when this presentation was written, the situation is not the same today. So things are changing very, very quickly. But you do need to keep in mind that the platform, because it is so powerful, you know, as they say, with great power comes great responsibility. Because there is so much power, you also need to be very cautious when you enable things. So that's it in terms of serverless questions.
Does anyone have any questions? Yes.
So I guess for me, the most interesting part was the exfiltration bit there, and you did sort of address it in the VPC part, which is, you know, it's good practice to lock down that network layer. But I found it really interesting that you're able to invoke the tar binary from the actual, I assume it's Amazon Linux that these things run on, the Lambda.
Yeah.
So there's probably an unlimited number of binaries baked into that OS distribution. Are they all able to be invoked from any Lambda function? And is there anything to prevent that?
So this goes back to another thing that I mentioned, which is the elevated permissions that you gave to the Lambda function. By default, it's not able to invoke executables. But here, it was manipulated to be given full access. Now, again, by default, you're not supposed to give it full access, but those examples that I gave basically kind of push you gently without you maybe even fully realizing that sometimes you do need to give this full access because you're using some third-party components or following some Amazon-provided code.
Okay. Thank you.
Okay, and just it is, as I mentioned at the beginning somewhere, it is running a Linux container, so, okay.
Anyone else? Well, I thought that was awesome. Thank you very much, Michael. If everyone could give him a round of applause.
Thank you.